Welcome to an overview about my NEA project. This is the starting screen where users will first go when they want to access my system. From here, we are going to log on with student ID 2, which is an admin account. That's what it's been set up to be. So when we log in with an admin account, we will automatically be redirected to the admin homepage. From here, we have a variety of options which we can do. We are going to start by creating a new user to use our system. So when we navigate to manage users, we are going to add a user. This is a page to create a new user. The student ID is optional. If we put one in, it will use that student ID for the system. However, if we don't, it will automatically generate one and tell us what it is for us to sign in. If the user is going to be an admin, we tick this box, and the following selection boxes are hidden so that we do not input unnecessary data. However, we are going to create a student. Let's set the password to be 1234 with an optional student ID. The first name will be NEA and the surname will be testing. This user will be in year 9, in Vikings, and as a female. So let's create this new student. As we can see here, the new student's ID is 244. So if we navigate to the home screen, manage users, and see all users, here we can see our recent user that we've added, who is in year 9 with the first name NEA, AA as I had put in, and last name Testin. If we click on them, we can see slightly more information about them, and we can edit this information too. And to make sure that nobody accidentally changes stuff they didn't mean to, you need to click to confirm your options. If the user wanted to, they could also delete them here. However, we are just going to change this gender to male, click to confirm our option, and save. And as you can see, we have successfully updated the information for this user. Now we are going to create a new possible event to add to our competition. As we are doing coding and computer science, we are going to have a coding competition. Is this a track event? No, because obviously coding is not. So here we need to input 4 ability levels. These are going to be the levels that students could be at. So for abstract system, we're going to have first ability level to be less than 10 minutes. This is how long it's going to solve our code, or whatever challenge we are doing. Second ability level, third ability level, and fourth. These are just auto-filled because I've previously used the system. However, you could obviously enter whatever you want. So I'm now going to create this new sport. And coding competition was successfully created. Now I'm going to go back to the home page and let's create a new competition for students to be able to sign up to. So the competition name is going to be NEA test. This is going to be on in June on the 24th, the date of my final test, A-level exam. So here we can choose, let's say, coding and the 100-meter race. So in here we need to choose the number of competitors per group, per gender for the specific event. This should be a multiple of 4, however, if it isn't, it will automatically be rounded up to a nearest multiple of 4. So let's say for 100 meters we are going to have 12, and coding, lots of people, so 16. And now we're going to create this event. And as you can see, the event has been successfully created. Now let's log out of this side. As you can see, we have a notification telling us we've logged out, and let's log on to the student ID. Just now we created a student ID 244 with a password 1234. So let's log in using that. As you can see, we have successfully logged in, and the system has fetched our name and last name to have here. So let's sign up for this competition we just created. We created NEA test, and as you can see, the students can now sign up for this. Here we can choose our first, second, third, fourth, fifth choice. We need to sign up for 3 to 5 events. If we sign up for multiple of the same, the latter choices will be discarded. These are radial buttons so that you cannot sign up for multiple of the same choice. So we're obviously really passionate about coding, so first choice. Second choice, 100 meters. And because we have to sign up for 3 to 5, we need to choose coding as our third choice. However, this will be discarded as only the first choices will be counted. This works better if you have multiple sports that you can sign up for. And now let's select our ability level for these. We're obviously really good in coding, so let's select less than 10 minutes, and not as good in sports, so we're going to select 14 to 16. And now we're going to submit this, and we have successfully signed up for a competition. Now we're going to log out and proceed back to the admin account to see how we can progress from here. So here we are going to manage existing competitions. And here you can see this competition we just created. If we go to view, we can see that somebody called NEA test has signed up for 100 meters and coding. However, we do not care about that at the moment, so we are going to edit this competition. In here we can also see that NEA test has signed up and allot students to their events based on preference. If we navigate to the individual student, we can change what sport they're allocated to and see a bit more information about their heat. However, for the moment, we are just going to allot students to their events based on preference. Now we are going to navigate to here, and this is my main code for this system. So, when that button was pressed, what actually happened in the background was this little piece of code was run, allot competition. It took the competition object, instantiated it, and then ran it before telling the user when this has run successfully, it has been successfully completed. So now let's look a bit more about how this code actually works. First, a student object is created for each student participating in this particular event. Their information is fetched from the database and they're instantiated. Also, sport objects are instantiated for each of the possible sports that's in this particular competition, which again are fetched from the database and instantiated. They are either field or track events depending on what specific event they are, which both inherit from the sports class. So then we have the actual competition. This competition is made up of year groups, houses, genders, which are all aggregation. So here we can see that the students will be sorted into their particular year group, gender, house, and gender. So in here, the actual sorting happens. So first, a bit of instantiation happens, and then when the actual program is run, it first sorts out how many people want each event, and then allocates the events where there are more slots available than people who actually want that event. It then proceeds to allocate any events where there are more students who want the event than possible sports. It then takes a bunch of different selection criteria and eventually whittles it down to ensuring that all the slots in each of the events have been successfully filled. Once all of this is complete, through a variety of different selection statements and sorting statements, then finally the database will be updated at the bottom with placed back into database. This takes all of the information from all of the students and sorts it and puts all that information back into the database. For example, what each student has been allocated to, and if it's a track event, what heat they are in. This code relies heavily upon a few models, including a stack, a queue, and a queue to help supplement these algorithms. So this is a brief overview of my code to run all of this. And as you can see here are all the different HTML templates to run all of the pages, and a bunch of different Python files to control all of the other methods for all of the other information that you saw happening. So as you can see, the event that we had previously talked about has been successfully allocated. Now let's talk about managing an existing competition which has a few more students in it. Let's look at demo comp instead. As we can see here, these two are the students who have been signed up for this event, and let's go look at what Oliver can see from his side. So if we proceed to student 1, which is the student ID corresponding to Oliver, when we log in, we can see welcome Oliver. And now if we go to view allocations and select demo comp, we can see that Oliver is not competing in 100 meters, however has been allocated to javelin, as is correct according to the algorithm. If Oliver was in the 100-meter event,
if we look here, when we go to Oliver Eger's account, we can go to view allocation, demo comp, and here we can see that Oliver is allotted to javelin and not to 100 meters, as that's for our other user, just as we had expected and seen on the previous page. If we now go to our other user, user 242 with the password 1234, and we go to their allocations, view allocations for them, demo comp, we can see that they are allocated to the 100 meters in heat number 1 and are not allocated to javelin, as that's where Oliver is. So this is exactly what we had expected and what our complex algorithm should have done. Thank you very much for listening to my NEA demonstration, and I hope this has helped you understand it better.